Greetings everyone. I am Arulmolinathan, Assistant Professor from Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this session, we are going to see comparison of axial and centrifugal compressors. Axial compressor is an air compressor that can continuously pressurize air by rotating its blades. The gas or the working fluid flows in a parallel direction to the axis of rotation. On the other hand, it is known as axially. A single rotor and a single stator combined together form a stage where the rotor is a rotating blade and the stator is a stationary blade. The rotor imparts the kinetic energy on the blade and the stator converts the kinetic energy to the pressure energy. When the rotor is rotating, the kinetic energy as well as the pressure energy increases. Altogether, in a stage, the pressure will increase. To get the required pressure, any number of stages can be stacked together and a multi-stage compressor can be made to reach the required pressure. Axial flow compressors produce a continuous flow of compressed gas and have the benefits of high efficiency and large mass flow rate. The centrifugal compressor, on the other hand, has an impeller inside a casing to increase the kinetic energy, and it converts the kinetic energy of the working fluid to pressure using a volute casing or a divergent outlet passage called the diffuser. In the impeller, both the kinetic energy and the pressure increases. In the diffuser, since there is no work being done, the pressure alone increases. Centrifugal compressors are particularly suited for compressing large volume of gas to moderate pressures. For an axial compressor, the advantage is it has high peak efficiency, small frontal area, straight through flow allowing high ram efficiency, increased pressure rise due to an increased number of stages with negligible losses, good efficiency over narrow rational speed range. Disadvantages is it is very complex to design first of all, then it is difficult in manufacturing, expensive because it is difficult, it is heavier weight when it comes to multiple stages, starting power requirements are high, sensitive to aerodynamic stall and angle of attack, sensitive to flow disruptions. Applications is that it can be used in high speed ship engines, small scale power stations, blast furnace air separation plants, most importantly aircraft turbojet engines, then land based gas turbines. On the other hand, for a centrifugal compressor, the advantages is it is reliable, low maintenance, low weight, easily to manufacture, fewer rubber parts, relatively energy efficient, insensitive to flow disruptions, wide range of rotational speed, no specific foundation required. But the disadvantages are large frontal area for a given airflow rate, which will increase the drag of the entire engine when fitted in a large aircraft. Unsuitable for very high compression, limited pressure, sensitive to changes in gas composition, sophisticated vibration mounting is needed. Vibration is one of the biggest problems in centrifugal compressor. Application of centrifugal compressors are gas compression in oil platforms, LPG storage and transport installation, the turbocharger in many sports cars, turbochargers in diesel engines, small turbofan engines use centrifugal compressors where a small mass flow rate is required, will be available and high pressure ratio will be required, small turbojets and turboshaft engines and as pumps in rocket engines. Now coming to the comparison between axial flow compressor and centrifugal flow compressor. Axial flow compressors direction is parallel to the axis, but whereas in a centrifugal compressor it is radial in axis. In axial flow, the mass flow rate can be up to 100 kg per second, but whereas in centrifugal it can be up to 15 kg per second. Axial flow can be used in large engines. Since only a small mass flow rate can be used, centrifugal compressors can be implemented only in small engines. The isentropic efficiency of axial flow compressor is very high, around 85%, and for a centrifugal compressor it is 80%. And it is easy to have large number of stages in axial flow compressor, but in centrifugal compressor, if the number of stages increases, the weight increases drastically, so multi-staging is a complex one. The thermal efficiency of axial flow is around 94%, but whereas in a centrifugal compressor it is 85%. Axial flow compressor needs high starting torque, but in a centrifugal compressor a small torque is required. Axial flow compressor is highly sensitive to higher altitudes, but centrifugal compressor is lesser sensitive for higher altitudes. Pressure ratio for stages is low in axial flow compressor. The pressure ratio for stages is high in centrifugal compressor. The pressure loss in axial flow compressor is low, whereas the flow in the centrifugal compressor is radial, therefore it has high pressure loss when compared to axial flow compressor. The frontal area for axial flow compressor is small when compared to centrifugal compressor's intake. The axial flow compressor is more suitable for jet engines than the centrifugal flow compressor because of this one criteria known as the frontal area, which will induce more drag. The axial flow compressor is very expensive when compared to the centrifugal compressor because of its complex nature. Thank you for watching this video. Happy learning. I also thank my students for supporting me to make this video.